Welcome back to chemical equilibrium and the equilibrium constant. Lesson 9a as well as lesson 9b would be on calculations. So we're going to calculate some equilibrium constants and concentrations. So our first example says a mixture of hydrogen and nitrogen reaches equilibrium in a closed container at a specific temperature according to this equation. 1 mole of nitrogen gas, 3 moles of hydrogen gas forms 2 moles of ammonia. Analyzing the equilibrium mixture gave the following results. Your concentration of nitrogen is 1 mole per cubic decimeter, concentration of hydrogen is 2 mole per cubic decimeter, concentration of ammonia is 2 mole per cubic decimeter. Calculate Kc. So first of all, we need to write down the expression for Kc. So it would be the concentration of ammonia to the power 2 divided by the concentration of nitrogen times the concentration of hydrogen to the power 3. So our ammonia concentration is 2, so it's 2 squared divided by 1 times 2 cubed. So this gives us an answer of 0.5. Now the meaning of this, because it's less than 1, we know that the equilibrium lies to the left. So your concentration of product compared to the concentration of reactants is lower than that of the reactants. Next we're going to look at page 186, example 1 there. So you can go to your textbook. They want us to calculate the Kc value. They say that we have hydrogen gas and iodine gas in equilibrium with hydrogen iodide. They say a mixture of hydrogen is allowed and the temperature is 448 degrees Celsius. We're not going to use that in a calculation. When the equilibrium is established, the concentrations are found to be. So I'm going to say concentration of hydrogen is 0.46 mole per cubic decimeter. Concentration of iodine is 0.39 mole per cubic decimeter. And the concentration of hydrogen iodide is 3 mole per cubic decimeter. And if my judgment is correct, the equilibrium would lie to the right, meaning there's a lot more hydrogen iodide than hydrogen and iodine. But let's see what the value of Kc would be. It's the concentration of hydrogen iodide to the power 2 divided by concentration of hydrogen times the concentration of iodine. So it is 3 squared divided by 0.46 times 0.39, which gives us 9 divided by 0.46 times 0.39 50.167. So this is much bigger than 1. So I can conclude here that the equilibrium lies to the right. So at 448 degrees Celsius, most hydrogen and iodine will turn into hydrogen iodide. That's basically what it means. Question 3. The equilibrium constant for the reaction sulfur dioxide reacting with nitrogen dioxide to form nitrogen monoxide and sulfur trioxide is 4. So they give us the value of the equilibrium constant at a specific temperature. It was shown that the equilibrium concentrations is as follows. The concentration of sulfur dioxide is 0.2 mole per cubic decimeter. Concentration of nitrogen dioxide is 0.1 mole per cubic decimeter. The concentration of nitrogen monoxide is 0.4 mole per cubic decimeter, and they want us to do some mathematics to find the concentration of sulfur trioxide. So first of all, we need to write the expression for Kc for this reaction. Please check that the equation is balanced before you do this. For 1 sulfur on each side, 1 nitrogen on each side, and 4 oxygens on each side. So here we go. Concentration of nitrogen monoxide times concentration of sulfur trioxide divided by concentration of sulfur dioxide times the concentration of nitrogen dioxide. So Kc is 4, concentration of nitrogen monoxide is 0.4. I don't know what the concentration of sulfur trioxide is, and we have sulfur dioxide 0.2 and nitrogen dioxide 0.1. If we do our mathematics correctly here, we should get the answer of 50.17. No, wait a moment. I'm in the wrong place now. Oh man. Okay, sorry. So it is 4 times 0.2 times 0.1 divided by 0.4. I get 0.2. Now this is not a Kc value, so I need to write mole per cubic decimeter. Good. Kc of 4 means that the equilibrium lies to the right. Next we're going to do page 186, example 2. That's where I was a bit mixed up. Some solid xy is placed in a 2 cubic decimeter, xy3 is placed in a 2 cubic decimeter, volume is 2 cubic decimeter, container and allowed to decompose. Temperature is 400 degrees Celsius according to the following equation. So it's 2xy3 solid is in equilibrium with 2xy, 2 which is a gas, and y2 which is also a gas. Calculate the equilibrium concentration of xy2 gas if there are 8 moles of Y2 in the container. So at equilibrium, you have 8 moles of Y2 gas. Now, to calculate concentration, we take moles divided by volume, so it's 8 divided by 2, and we get 4 mole per cubic decimeter. Now, the trick here is to see that XY3 is a solid, so it will not affect the concentration, the Kc value, the equilibrium constant value. So our Kc expression is only calculated by using XY2 concentration squared times Y2's concentration. Now they said that the Kc is 16, so 16 is concentration of XY2 squared times 4. So we need to do some simple mathematics. XY's concentration, XY2's concentration is 16 divided by 4, which is 4's square root. Root of 4 is 2 mole per cubic decimeter. The next video will continue with the examples that we are busy with. Thank you for joining.